So students, we have already learned and explained law of conservation of linear momentum. So now we will see its proof, that is proof of law of conservation of linear momentum from third law, that is using third law. From third law we can obtain the proof of law of conservation of linear momentum. So let's see, get started. So this is method 1. There are two methods. Okay, so I will discuss one by one. So from Newton's third law of motion, we all know that action equals to minus reaction. So I have already discussed earlier about the two bodies. When the two bodies, that is body A and body B, when collide with each other, a PA is the action, that is the force exerted on the body A due to the second body, and PB is the reactional force. Okay, if PA is the force exerted by B on A, then PB is the exerted with the force exerted on B by A. So action equals to reaction. Clear? From third law we all know that force on first body equals to minus force on the second body. Now impulse of force on A. Now since these two forces, why impulse comes? Since these two forces collide with each other, it means collision takes place. So obviously the collision will takes place for a small moment of time, isn't it? Small period of time. So as we have already known that when any force acts on a body for a small period of time, it creates impulse. So since this collision takes place for a small period of time t, suppose, so impulse on force A equals to its rate of change of momentum. Very easy. Okay, we have already learned that is F into t is equal to mv minus u. So Pa into t is the time of collision between two bodies. So PAT is equal to m1 v1 minus m1 u1. That is final momentum of the first body and the final momentum and the initial momentum, which is the rate of change of momentum of the first body. So similarly, in case of second body, impulse on it obviously will be is equal to its rate of change of momentum, that is PBT, that is m2 v2 minus m2 u2, final momentum minus initial momentum. T for t time their collision persists, stays for time t. So if it means impulse on A equals to impulse on B, negative. So since Pa equals to minus PB, so we will just directly put the values. Okay, that is m1 v1 minus m1 u1 divided by t equals to minus m2 v2. Clearly, no confusion here. So t cancel. So here you can see m1 v1 minus m1 u1 is equal to minus m2 v2 minus m2 u2. So minus minus plus. So we will convert, shift m2 u2 towards the left side. So we get, okay, that is minus minus plus, and if we shift minus m1 u1 towards the right side, that is we get m1 u1 plus m2 u2, and if we shift m2 v2 towards the left side, we will get m1 v1 plus m2 v2. Very clear. m1 v1 minus from right hand side to left hand side plus m2 v2, and minus m1 u1 will be shifted towards the right hand side, m1 u1 plus minus minus plus m2 u2. So arranging, we have got m1 u1 plus m2 equals to m1 v1 plus m2 v2. Just see the previous video, that is the linear momentum before collision. Before collision their velocity were u1 and u2, and after collision their velocity were v2 and v2, v1 and v2. So the total momentum before collision equals to total momentum after collision. This is the plain general theory. It can also be proved easily by using integral calculus. Clear? So let's see. Now suppose two bodies of masses m1 and m2. Clear? Moving with velocities v1 and v2. Very clear. Linearly, that is along straight line, and collision takes place, collide with each other. Mind it, in absence of any external force, that is only action and reaction. So obviously a force will create, so obviously an acceleration will create since change in velocity. So acceleration developed in the first body is dv1 by dt, that is derivation of the velocity, change in velocity, and acceleration developed in the second body, that is dv2 by dt. Clear? Now let suppose F12 is the force acting on the first body due to second body, by the second body, and F21 is the force exerted on the second body due to the first body. Now from Newton's third law, action equals to minus reaction. So substitute the value of F12. We all know that F is equal to ma. So F12, since it is the force acting on the first body due to second. So here every data will be due to the first body. So m1 dv1 by dt is equal to minus m2 dv2 by dt. If this is 1 due to 2, you can also assume this is the force exerted on the second body by the first body. So in that case, F21 will be force on the first body or the second body. Opposite, doesn't matter. So m1 dv1 dt is equal to minus m2 by dv2. Okay. Arranging all this towards the left side, shifting, converting, we have d and dt common. So m1 v1 plus m2 v2 is equal to 0. We all know that the derivative of, isn't it, if we the integration, isn't it, the derivative of a constant is equal to, okay, is 0. The integration of a constant is 0. Clear? So m1 plus v1 is equal to constant. If we integrate it, isn't it, if we integrate it, we will get its 0, isn't it, derivative. From integration we get from here. And if we derivative this side with respect to t, the derivative of constant is 0. So by integration we get m1 plus b1 is equal to constant. Because derivative constant is 0, it means a total the linear momentum is conserved, that is constant, uniform. So this is nothing but law of conservation of linear momentum. So prove. So you can prove law of conservation of linear momentum using any one method, either one or two, according to your own choice, according to your desire, which one you will find easier. Clear?